Hello, welcome back. Our quote of the day today is the expert has failed more times than the beginner has tried. Our agenda for today is I can solve a system of equations graphically. So we're going to talk about lesson 3.2 and see how we can solve graphically. But always click on Joey, tell Joey how you doing this morning. And let's get ready to look at our lesson 3.2. So looking at lesson 3.2 here, we're going to graph a system of linear inequalities. Now, a system of linear inequalities is a set of two or more equations using the same variables. So it might be something like y equals 3x plus 2. And my second equation would be y equals negative 2x plus 5. Now, these two equations usually are held together using a curly bracket so that you know that it's a system. The solution to a system of linear inequalities is the point of intersection of the lines. That means that it's the point that makes both equations true. So looking at these systems that are graphed below, we're going to find the solution to these systems. So looking at letter A, here's the point where they intersect. So the solution to my system is -1, +1. Remember that we name a point using x comma y. So this point is at -1 on my x-axis and +1 on my y-axis. Looking at B, again, here's where they intersect. And my point is 2, 2. Again, not only is this x comma y, but looking at my coordinate pair, make sure that you have parentheses and a comma. Now we're going to see if the ordered pair is a solution to the system. So here are my systems. Again, they're held together with that curly bracket. And we're going to check to see if 3, -2 is a solution in this system. Now, other than graphing, one way that we can find out if it's a solution is to substitute. So that's going to be our strategy for this. So this is our x and our y coordinate. So I'm going to take my first equation and I'm going to rewrite it right here. X plus 2y is equal to 7. So I'm going to substitute in 3 for x, using parentheses when I substitute in a number, and 2 for y. And I'm going to check to see if this is true. Does 3 plus 4 equal 7? It is true. So that means that 3, 2 is a point on that first line. However, we need to check to see if it's also a point on my second line. 3x minus 2y equals 5. And again, I'm substituting in 3 for x and 2 for y. 3 times 3 is 9, minus 2 times 2 is 4, and 9 minus 4 is 5. So because it is a point on both of those lines, it is a solution for that, or that ordered pair is a solution for that system. Now let's try letter D. Here is my x coordinate and my y coordinate. So I'm going to substitute in to each equation. I'm rewriting the first y. I'm going to substitute in for y. 5 is equal to 2 plus 7. Oh my goodness. Okay. And I'm going to color code a little bit. So my y was green. My y is green. My x is yellow. My x is yellow. All right. Is 5 equal to 2 plus 7? No. 5 is not equal to 9. So it is not a point on that first line. So this is a no. I don't even have to substitute it into my second equation. Looking at the next page in our notes, we're going to graph and find the solution. So when I graph, I'm going to first color code each of my lines. This first one's going to be in blue, and my second line is going to be in pink. So for my blue line, I'm going to rewrite my equation just so I know which equation I'm talking about. And I'm going to identify my m, my slope is 3, or 3 over 1. And my b, or my y-intercept, is a -3. And it might be helpful for you to write at the top of this, y equals mx plus b. So now I'm going to begin with my b on my y-axis at -3. And then I'm going to move with my rise over my run up 3 to the right 1. Up 3, right 1. Up 3, right 1. Up 3, right 1. Once you have those points plotted, you connect them with your straight line. We draw arrows at the end of our line. And we label our line with our equation. I'm going to make it sit right on this equation, y equals 3x minus 3. So that's done. I've graphed my blue line. Now I'm going to graph my pink line. Y equals -1/2 x plus 4. So again, my slope is -1/2. That's my rise over run. And my b is +4. So I'm going to start at +4 on my y-axis. And I'm going to move down 1, right 2. So down 1, right 2. When I do that, notice that I hit this point. I like to circle it when I hit it. I hit that point. That point is the same. It is both blue and pink. So I like to circle it. And then I'm going to go down 1, right 2 again. Down 1, right 2. Down 1, right 2. And I'm going to connect my points, making sure that my line is lined up and goes all the way off my graph. And I'm going to label that line as well. Y equals -1/2 x plus 4. However, I need to state my solution. So what I can do is I can just name the point right next to that point where the two intersect. So +2, +3. over 2 on my x-axis, up 3 on my y. Looking at number 2, I'm going to do the same thing. However, notice that my first equation is not in slope-intercept form. So I'm going to have to move it into slope-intercept form first. So to do that, again, slope-intercept form means that you have your y by itself. So to move things away from your y, you're going to have to add an x to both sides. 2y equals x plus 3. And then divide by 2 to get x by itself. And you get y equals, and this is x over 2 technically, plus, 3 over 2. That is not a nice one. Not nice. So what I would do for this one is to type it into our calculator to get our table. So again, to use our calculator, you're going to go into y equals, then you're going to hit second graph to look at your table. So I'm going to give you a minute to do that. When you go into y equals, remember that to get a fraction, I'm going to write a note. For a fraction, you're going to hit alpha and then y equals. All right. Now I've written down here what your table should look like on your calculator. Now I want you to pay attention. We don't have whole numbers the whole time, do we? I don't want to graph these fractions. I really don't. So what I'm going to do is just pick those numbers, the ones that I highlighted, that have whole number coordinates, and I'm going to graph those. So I'm going to graph -3, 0. That's right here. Then I'm going to graph -1, +1, and +1, +2. Now you could have more points on this graph. Usually I like to have about 5, but 3 points technically work. Technically 2 points make a line. So I'm going to connect those with a line, drawing my arrows, and I'm going to write my original equation on this line. 2y minus x equals 3. I still have to graph my other equation though. It's right here. And I'm going to graph that one using slope-intercept form. I'm going to just write it up above. My slope is 1/2. My b is 2. So I'm going to begin at 2 on my y-axis and move up 1 over 2 to the right, up 1, right 2, up 1, right 2, up 1, right 2, up 1. Oh my goodness. I don't know what's happening. These lines will never, ever touch. Now, there is a way to tell that those lines will never touch. They're parallel to one another. Remember that term? So these lines are parallel. They will never intersect. So there is no solution for this system. If the lines don't touch, there's no solution. If the lines are the same line, then we have infinite solutions because every single point is the solution. But right here, these lines will never touch. There is no solution. However, I'm not finished because I never labeled my lines. Let me label my pink line. Y equals 1/2 x plus 2. All right, now we're going to look at our agenda, finish up with our practice. Your practice today, you have a whack-a-mole activity on Kami that's posted to Classroom, and another activity is to do a couple problems with this on Delta Math. All right, please ask questions when you have them, but I will see you in the next video.